Alright, today we're going to be figuring out how to transform our quadratic equations from standard form, which is the y equals ax squared plus bx plus c, to our vertex form that you learned about yesterday, which is y equals a x minus h squared plus k. Before we actually get into it, we just want to talk real quick about the differences between the standard form and the vertex form. There's only a couple of things that you can get from standard form. The a is still our vertical stretch or compress, and if it's negative a, it still reflects. But the only other thing we can tell from the standard form is c, which is the y-intercept, which we can write as 0, c. But the vertex form gives us a lot more information. It gives us all of our transformations. It gives us our vertex, which I always say is the opposite sign of h and k. And we can tell our axis of symmetry, which is the line that cuts the parabola in half, as x equals the opposite sign of h. So in order to get our equations from standard form to vertex form, we're going to be doing something that's called completing the square. We've got 6 steps. We're not going to do all of them every time. There's some of them that get to skip over. The first thing we always want to do is make sure that we have our equation in standard form. We want ax squared plus bx plus c all together. Also, to make it correct, we need to change it from equals 0 to y equals. Change the 0 to y. Next thing we're going to do is we're going to move the constant over to the other side of the equation, and we'll have an example, a couple examples for you in a moment. Then we're going to factor out the greatest common factor if possible. That's the step that sometimes we'll skip if we don't have a greatest common factor. Next, we're going to be actually doing the completing the square part, where you're going to take b, cut it in half, and square it. And we're always going to be adding that to both sides of the equation. The 5th step, we will factor a quadratic. We will have a quadratic. It will always be a double root. And then the final part, we're going to move what will be a new constant back over. All right, so here's our first example.
Don't change classes.
I've got 0 equals x squared plus 2x plus 4. The first thing we ought to do is make sure we have it written as y equals. So we're at y equals x squared plus 2x plus 4. Now the next thing that we're going to do is we're going to move our constant over. So I always write it like this, y minus 4. And I put an empty spot. We're going to fill it in later, and I'll show you with what. Equals x squared plus 2x. And we're going to have another empty blank that we'll fill in a minute. So that's moving the c over. Now I've got to do, if you look, there is not a greatest common factor here, other than, and we're only talking about the coefficients. The x's does not count. We always leave an x squared in the x. We don't factor out a greatest common factor with our variables, just the coefficients. So the next thing I'm going to do is the completing the square part. I'm going to do b cut in half squared. So if I do that, b is 2, cut in half means this is 1, 1 squared equals 1. That's the part that's going to go in my boxes, here and here. It has to go on both sides to balance your equation. So the next part we're going to do is combine our like terms over here. Negative 4 plus 1 is 3, minus 3. Equals, and over here, we're going to write this, we're going to factor it. So what multiplies to give me 1, but adds to give me 2, and that would be 1 times 1. So it's a double root. We're going to write it as x plus 1 squared. Then our last part is to move our new constant back over to the other side by adding it. So I get y equals x plus 1 squared plus 3. So now with this, now I can identify my vertex as opposite sign of h, which is negative 1, and the same for k, which is 3. I can also now tell you that my axis of symmetry, which is always written as an equation, is going to be x equals opposite of h, negative 1. All right, our next equation is a little bit tougher. So you've got to make sure you pay attention to all your details. So we're going to go through this. I already have it as y equals. So the first step is we got to move our constant over. So we're going to write y plus 4. And again, we're going to leave an empty spot equals negative 3x squared plus 6x. We're going to have an empty spot. So the next thing that it says to do is to factor out the greatest common factors if possible. Remember, I said that's only the coefficients, never the variables, so I'm only going to be factoring out negative 3. Always want x squared to be positive when I factor it out. So I got y plus 4 plus our empty spot that will fill in equals, I'm factoring out negative 3. That gives me positive x squared minus 2x in my empty spot. Next thing I'm going to do is do the completing the square. So I got to do my b, which is negative 2 now, over 2, and square it. So that's going to equal 1. It's negative 2 over 2 is negative 1. Negative 1 squared equals positive 1. Here's where you've got to be really careful because we are actually balancing our equation. I am going to put 1 over on this side, but if you look, it's in parentheses, and if I actually distributed this negative 3, I'm actually putting negative 3 in here. So that means I need to balance it by putting negative 3 over here. Because I'm going to multiply the greatest common factor times the completing the square 1 that I got. Now I'm going to go ahead and finish out my problem. On this side I get y plus 1 now equals negative 3. And again, I'm going to do my factoring over here. What multiplies to give me 1 but adds to give me negative 2, which would be negative 1 times negative 1. So that's my double root, x minus 1 squared. And then I'm going to go to my last step, which says to move my new constant back over. So I get y equals negative 3 x minus 1 squared minus 1. And again, from this, I can tell my vertex, which will be opposite of h, which is positive 1. K stays the same at negative 1. The axis of symmetry is going to be x equals positive 1. Alright, so here's our last example that we're going to give you. It's y equals 2x squared plus 8x minus 3. I'm being lazy. It's already in standard form, but remember I might give you one that's not, and you'll have to make sure you write it in standard form before you start your problem. So again, the first thing I'm going to do is move c, the constant, over. So I'm going to have y plus 3. We're going to fill in an empty spot, again, equals 2x squared plus 8x with another empty spot that will fill in. Again, this one has a greatest common
Mr. Blanchard, can you come back up to the front, please? Thank you.
This has a greatest common factor, not the variables, just the coefficients of 2. So I'm going to factor that out. So I factor out the 2. That gives me x squared plus 4x plus whatever we're going to fill in there. Now I'm going to do my completing the square part. I'm going to take b, divide it by 2, and square it. So 4 divided by 2 is 2. 2 squared gives me 4. Again, 4 is what goes over on this side, but you've got to remember to balance it with our greatest common factor. So I'm going to take the 2 times 4, which will give me 8 to balance out my equation on the other side. Now I'm going to finish out some stuff. I got y plus 11 equals 2, parenthesis, and again, what multiplies to give me 4, but adds to give me 4, should always be a double root, 2 times 2. So this is x plus 2 squared. Last step, we're going to move our new constant back over. Y equals 2, parenthesis, x plus 2 squared minus 11. My vertex then will be negative 2, negative 11. And the axis of symmetry is going to be x equals negative 2. Okay, for your homework, since you've got your notes taken, the one last thing I want you to do is we want you to try these two equations. The first one's y equals x squared plus 6x minus 10, and this one says 6x minus 3x squared equals negative 12. I'm trying to trip you up, so make sure you're careful about these, and then have your questions ready for when you come in the next morning. Good luck!